Hello, Dania. I wanted to make you a video to talk to you about this assignment. I see that you have handed it in twice now. Just to let you know that these assignments are marked assessments. Once you have decided to hand an assignment in for marking, it's like a test. When I've marked it and sent back your mark and your comments, you cannot hand it in again. You need to check with me before you hand an assignment in if there's something that you don't understand, or check with me on the practice questions that you're doing in each lesson to make sure that they're correct as you move along. As soon as you've handed in an assignment, then that is the one and only chance to get the marks on that assignment, okay? Now, I want to explain to you the idea behind the asymptotes. And I think if you read back through the lesson on the asymptotes and look at the examples that I've provided there, that you will see that it's quite a bit different than what you're handing in on your assignment. So I'm going to go through B and show you what's expected for a perfect answer on a question like this. And I'm hoping that you can review this and learn it, and you will have another opportunity to show me that you understand the asymptotes when you complete the Unit 4 test on curve sketching, and also the midterm exam, which comes after Unit 4, because both will require you to use asymptotes. So let's start with B. And I'm not sure what this notation is here that you're using. It might be something that you've learned before. It's not something that's the proper notation when you're working with asymptotes. And so I need for you to do it in the proper way according to the lesson that I provided and the examples. What we would do here is we would show that x squared minus 2, when we set it equal to 0, has a solution of x squared equals 2, which means that x has to be plus or minus 2. Then you would say, therefore, the vertical asymptotes are x equals root 2 and x equals negative root 2. Now, I know you have that listed here, but you need to follow the same procedure as what I've just laid out here in order to show how you're finding the vertical asymptotes. Now, the next step is for you to test the asymptotes. And again, if you look at the lesson, you'll see an example. I think there's a video there showing you how to test the asymptotes. And that's the most important part, because we want to graph this function. And so we need to know what the function is doing as it's approaching these asymptotes. It's a very important part of being able to put the function on the Cartesian coordinate system on the graph. So what we need to do, let me just make this a wee bit smaller. There we go. What we need to do to test our asymptotes is we're going to find the limit of the function as x approaches the asymptotes. Let's start with the positive asymptote. So we're going to say root 2 from the left, and the limit as x approaches root 2 from the right. Now we're also going to repeat this for negative 2 and do exactly the same thing, test it from the left and the right. So root 2 is approximately 1.41. A value that would be just before root 2 on the graph might be x equals 1. So if I substitute positive 1 for x, then I'm going to get 3 over negative 1, which is negative. That tells me that this graph is approaching negative infinity as it approaches the asymptote. So if we have a quick look at the graph, here's 1, here's 2. So our asymptote is approximately here at x equals root 2. As we approach this asymptote from the left, our graph is approaching negative infinity, which means that it's going to look like that. So if we do the same thing for approaching from the right, a value that we would pass through just before we get to root 2, coming from the direction from the right, would be positive 2. So we're going to do the same thing now. We're going to take 3 over x squared minus 2, and we're going to substitute 2 in for x, and we end up with 3 over 1, which is positive, which means that the graph is approaching positive infinity as it moves towards the asymptote from the right to left direction. So let's draw that. It's going to go up like that. So it gives us a really good idea of what the graph is going to look like around this asymptote, and it really helps us to determine the shape of the graph. Now, the other part that you're missing is the horizontal asymptote. So you were asked to find both asymptotes, and on all of these questions you did not indicate what the horizontal asymptote was. For the horizontal asymptote, if we're looking at a function 3 over x squared minus 2, because the degree of the numerator is smaller than the degree of the denominator, we will have a horizontal asymptote. As we take the limit of this function as x approaches infinity, it's going to make the bottom, or the denominator, very, very large, and the top is only 3. So 3 divided by infinity is approaching 0. So that tells us that we have a horizontal asymptote at y equals 0. Again, if you look back to the video that's included in the lesson for this topic, you'll see how to test the horizontal asymptote to see how the curve is behaving. We know that the x-axis, or the line y equals 0, is the horizontal asymptote. Now we can already predict from the graph that we've drawn using the vertical asymptotes that the graph is going to continue to stay above the horizontal asymptote on this side, and that the graph will stay below the horizontal asymptote as it approaches negative infinity for the x values. The way that you test this is you're going to find the limit as x approaches positive 10 of 3 over x squared minus 2 minus the horizontal asymptote, which is 0. 3 is considered a really large value of x, so that, or 10 is considered a really large value of x, and that's why we're using that as our testing value. So 3 over 10 squared minus 2 minus 0 equals 3 over 98. And all we care about is whether or not that's positive or negative. Since it's positive, it tells us that the curve will stay above the asymptote. Now you're going to test the limit as x approaches negative 10 in the same way, and I'm sure that you will find, if you do all of this work in between, that this one will be below the x-axis, or below the asymptote. That is a complete solution for B. If you fill in the other tests for the other values, that was what I was looking for each of these questions. Unfortunately, you didn't provide me with anywhere near that. And again, I encourage you to go back and look at the lesson and the examples for this topic and follow the examples exactly when you're doing the assignment questions from now on. Please let me know if you have any more questions around this assignment. Thank you.